Hello and welcome to SudoKanard. Let's have a look at this Palindrome Sudoku puzzle that I created for the latest round of the WPF Sudoku Grand Prix. And the rule is that all of those lines are palindromes, which means that they read the same in both directions. It mainly means that those two digits are equal, those ones are equal, those two ones are equal, those two ones are equal, and the same like this. And this is all about geometry, and this is quite a hard puzzle. It was worth 75 points and could have been worth more, I think. Well, if I had had to take part in the round, I think I would have strongly struggled on this one. So, what happens? You see that those three digits are the same as those ones, so they're all different from 9, 4, 6, and 8. That's a thing. That's a thing, but that's still 5 candidates. That's not very satisfying. So let's look at it in a different manner. So 5 obviously is not here. 5 is different from those digits, so it's different from those digits. So on this row, 5 can only be here. In the same manner, 1 is not here. 1 is not here, so by the palindrome it's not here, so it has to be here. And because of this one, 1 is here. And now you see that 1 is not on this line. So 1 is not here or there. And by the palindrome it's not here, and it's not there by Sudoku, so 1 is here. Now, there's something similar here. 6 is not here. It's not here, so by the palindrome it's not here, so 6 is here. And 4 is not on the palindrome, it's not here. It's not on the palindrome, so 4 is here in this column, and 5 is here. Now, 8 is not on the palindrome, so it's not here, so it has to be here on this row. And this now must be 9, I think, yes, because 9 is not on the palindrome, so on this column, 9 can only be here. And you see that the remaining digits here are 2, 3, 5, and 7, but 2 is not here, now there, 3 is not here, now there. And, well, that's a bit unsatisfying to have 4 candidates in the cell, but that will make the explanations clearer, I hope. So let's finish the similar logic here. 2 is not on this part of the palindrome, so it's not here either, and on this row 2 can only be here. Now 3 and 4 are not on the palindrome, they are not here. So on this column they are not here, they must be here and there, so this is 3 and this is 4. And likewise, we can restrict those cells to 6, 7, 8, and 9. So there again, that's 4 candidates, which really sounds unsatisfying, I'm afraid. So where do we look next? Well, a place of interest is this, because this digit is different from those ones, and this digit is different from those ones. And you see that it's different from 1, 2, and 9, and 4, and 6. So this digit, actually, being different from all of this, has to appear here. So I use color for that. So I use color. I know that's really not easy to use colors when you're doing a contest, but I'm afraid I can't do anything much more satisfying. Right, so what can this digit be? Well, obviously it's between 3, 5, 7, 8, but you see here that it's not a 3. So that's not a 3. So this is 5, 7, or 8. And something interesting in that is that this digit here must appear somewhere here, so it's either this or that. something similar is happening here. This digit is different from 3, 4, 8, 5, and 1, and it's different from all of this. So this digit has to appear somewhere, well, in this cell. Let's use another color, let's say yellow. So those digits are identical. This is among 2, 6, 7, and 9, and you see that this is a 2, so 2 is removed as an option from those cells. And then we get a quadruple here. That's a 6, 7, 8, 9 quadruple. And one impact is that this digit is different from those ones, and it must be equal to this one. So this is not 8. Let's get some more color. And then, oh, sorry. I did something wrong. Oh. What did I do? Right. Now this 5 is not here, so 5 goes there. This is now 1, 2, 3 triple, but this can't be 1 or 2 by Sudoku, so that's a 3. This can't be a 4, it has to be a 6, 7, or 9. There has to be a 4 somewhere here. There has to be an 8 somewhere here. And that's interesting, because we see that, knowing that one of this must be 8, you see that one of those red cells will see the 8. So none of those can ever be 8. And that's interesting, because now this digit produces a 2, 3, 5, 7 quadruple, so that this digit is different from those and must be the same as this. Well, not sure this coloring will be useful for the rest of the solve, but we now know that this is not a 2 or a 3. Actually, this 2 is now either here or there, and it's either here or there. I'm not sure those pencil marks will help in the slightest. But similar logic may happen. This 6 does not appear here, so it's there. So 6 is not here, and it's not here by the palindrome. Where do we look next? Well, this digit here is not in this region, so it must be somewhere here, but I don't think that's useful for the time being. Perhaps I should look at this other digit, this one here, which is not, well, it's seeing 1, 2, 3, 5, 6, 8, so it must be among 5, 7, and 9. 4, 7, and 9, sorry. Oh, and I forgot, those are 4, 8, 9 triple, and there's no 4 here. Not sure that was very useful. But this 3 is not here. That's useful, so that's not 3 by the palindrome. We get a 5, 7 pair, so this is 2, this is 3, this is 2, this is 3, and down there we get a 1 and a 2. That was definitely useful. Well, I sure hope so. This 2 and this 2 and this 2, put a 2 here. We get a 3 here with those previous 3s, so this is now 5, 7, or 8. There's no 8 here. And all 4 values seem to be valid here. 1, 3, 5, 7, so this is 1, 3, or 7, this is 1, 5, or 7. Right, let's focus on this. You can see that there has to be a 4 somewhere here. So it's not possible that those two be both 4s. The value that is here has to appear there, so it can't be a 4. So this is 7 or 9. And we see that as a 7 or 9, it must appear somewhere there. But you see that this is different from that. This is different from that. So this digit is not here, it's not here. So this digit here must be somewhere here. But this digit is different from this one. So this digit here must be here. It is cloned in this position. Let's take another color, let's say brown, to denote this value. And then, so this is repeated here by the palindrome. And then the what? And then, well, I'm just looking for something to deduce from that. Oh yes, this value is here and there, so it must appear somewhere there. But it's different from that, so it must appear here. And knowing that this is the same as that, it has to be a 9. Well, of course, you could argue that using Penta for this is borderline cheating, because I can make use of colors, and I would be in a bad position if I tried to argue against that. But if you look at how Tantandai solves this, she publishes the solve on her YouTube channel. You'll see that she has manners of coloring with just small symbols or just surrounding something, circling a number, just underlying it with some squiggly drawing. She manages to do that. Well, let's look back to this. 9 is not here, so 9 is here. That's a 2, so that's a 2. And this is now, oh, we get a 6, 7 pair here, so this is not 7. We get here 1, 3, and 4, so this is 3, that's 1, that's 4. That's not 1. We get a 5, 7 pair here, so this is 3. This is 5, 7, or 8. So finding this 9 should lead us to near completion, but this is not done yet. Where else should I look? So this row needs 6, 7, and 8. So this is 7 or 8. This is 6, 7, or 8. I still need a 4 somewhere here, and actually 6, 7 here. Oh, and this is not a 9. That's it. That's a 6, 7, 8 triple. So 9 must be here. That's a 4. This is 5, 6, 7, or 8. So this is a 1, 4 pair. Still not quite finished. This, we still need 5, 6, 7, and 8, but there's a 5, 7 pair in this row, so this is 6 or 8. I still need 1, 6, and 8 in this row. That's not 6. Still need a lot of stuff. I must be missing something almost simple, I guess. But what is it? Probably something to do with geometry again. Probably something of the same kind as previously. So this, yes. That could be interesting. This digit is different from both digits here, and it's different from that by the palindrome. So this is the same as that. And it must appear somewhere there, but I'm not sure which one it is. Oh, that's it. There must be a 6 somewhere here. So those yellow cells contain a 7, and that should do the trick. So that's a 6, that's 8, that's 6, that's 8, that's 6. This is now 8, that's 6. 8 is cloned here. This can only be a 5, so the red cells are 7s. That's a 5, that's a 5, that's 5, and that's a 5 as well. Right. 4, 8, and 5 there, so this is 5, 4, 8, 1, 4, 8, so this is 1 or 8. That's an 8, that's 1, that's 4, 1, 4, 8, 4. The last 7. There's a mistake. Oh, that could never be a 5. What did I do? That's so typically me. 4, 8, and 6. That's a 6. 4, 8 here. So that's 8. That's 1. That's 4, 1, 4. 4, 8. So that's a 5 now. That's 7. That's 6. 1 here. And 8 there. And that completes the soap. So sorry for this blunder. But if you're a regular of this channel, you know it happens all the time. So that's it for this Palindrome Sudoku, which was a bit on the struggling side. And really this is all about geometry, about who goes where. And so that's it. Thanks for watching this video and see you soon on SudoKanard.